Hello everybody, and welcome to this video. This video will help guide you through activity 9.3. What does an electrical generator do? So our learning target for today is we're going to investigate how electricity can be produced. And my goal for you is to be able to explain how electricity is created by the time you get done with this lesson. Now, first of all, if you look at your book, if you log into your online textbook, or if you have a paper copy, if you open up the paper copy of the book, the directions are very vague. It simply says, your teacher will provide instructions for this page. Doesn't tell you what to do. It just says, I'm going to provide instructions. And I'll do that towards the, just a little bit later on. So my first question to you is, where does electricity come from? How did you answer that? What are you thinking? One of the more common answers I get to this question is, well, it comes from the outlets, it comes from the walls. But if you were to tear apart your walls, now don't do this at home or anywhere, but if you tear apart their walls, is the electricity being produced in your walls? So yes, it comes from an outlet, it comes from your walls, but where does it really come from? Does it come from your walls? Does it come from an outlet? If we were to tear apart the wall and if we were to investigate, we would see that your outlets are connected to wires. And if we follow those wires, eventually those wires, they'll go through your fuse box. They'll probably go through some transformers on the way to your house. But if you follow those wires will eventually take you to a power plant. Now, how does it get to your house? Well, we just answered that. It's going to come via wires. So a lot of these wires are buried. That's why it's always a good idea whenever you're working around a house, if you're going to do any type of digging, to call Digger's Hotline, because if there is an electrical line digging through your house or going through the ground and you're digging around your house, the last thing you want to do is sever that wire. One, it could eventually, it could kill you. You could get electrocuted. And plus, all your neighbors would probably be mad if you're the one who caused them all to lose power for the day. Now, when we talk about electricity, a lot of times you hear the word grid, the electrical grid. Or there's a lot of shows on YouTube and TV that talk about people living off the grid. And have you ever thought about what that means? Well, when you think of all the electrical lines running around Wisconsin, think of it as a large grid. And connected to the grid are different power plants. And we'll talk about some of the closer power plants to us. So all these power plants put electricity into these lines, and they call it the grid. And if you're connected to the grid, you have electrical lines coming to your house, and you have electricity. So living off the grid simply means you're not connected to those power plants. You produce your own electricity. So maybe you have a generator, maybe you have solar panels, and you may have those anyway. Maybe you have some wind turbines, and you may have those. So some people decide to live off the grid completely, meaning they're not connected to power plants. Where some people will have solar panels, they'll have little wind turbines, but they'll also be connected to the grid. A lot of times people will also have a generator in case they lose power from the grid. Maybe there was a windstorm and a tree fell over onto some power lines and now you're not connected anymore. So that way that generator will help produce electricity even though the grid right now is not functioning. So when we talk about things and we talk about power plants, think about the area we live in. Where do you think the closest power plant to Baraboo is? Now, when you start to think of power plants, what type of power plant are you thinking of? Because there's a couple different answers to this. When we talk about large scale power plants that produce a lot of power, and in fact, we got one of the larger power plants in Wisconsin located pretty close to Baraboo in Portage. It's called the Columbia Power Station or Columbia Power Plant. If you're talking about smaller power plants that produce quite a bit of electricity, but not nearly as much as the Columbia Power Plant, well, we've got a couple hydropower plants, a couple hydroelectric dams. One is located in the Dalles. So if you ever driving through Lake Delton and you go over the bridge to get it to downtown Wisconsin Dells, you can look off to the right and you will see the hydroelectric dam. And Sauk, it's a little bit harder to see, but I'm trying to think of my directions. It's north of the downtown area of Prairie du Sac or Sauk City. And there's a little park there. So you can go down into the park and you can see the dam. It's there. A lot of people like to fish in that area as well. Now, does Wisconsin have any nuclear power plants? Of course we don't, right? You never hear about them in Wisconsin. Of course, we don't have any, do we? Well, we actually have a couple different nuclear power plants in Wisconsin. So let's take a look at these power plants. First of all, here is the Portage Power Plant, or the Columbia Power Plant. Here they're calling it the Alliant Energy Power Plant. And here it says Wisconsin Power and Light. And I believe Wisconsin Power and Light and Alliant co-own it. Or at least that used to be the case. Now, where is this plant located? It's just located south of Portage. And what I did was I took a screenshot here of Google Earth. And one of the neat things about it is here's Baraboo. If you drive out of Baraboo on Highway 33 and you look straight across, you can actually see the smokestacks for the Columbia Power Plant. So they're so tall in the air, on a clear day anyway, you can see those stacks. So next time you do that, and you can see it's quite a ways away, look, you will see them. And sometimes you'll actually see them putting material out into the sky, and some people say, whoa, that's a lot of pollution. Well, there's probably some pollution in it, but a lot of it is actually water vapor. And when you look at the Alliant Energy Center, or the Alliant Power Plant, Columbia Power Plant, it actually has, it's basically two power plants in one, because there's two generators, there's basically two of everything. And which is good, because that way if one is shut down, and they do shut them down each year for routine maintenance for a few days, the other one can still be producing electricity. So how about those nuclear power plants in Wisconsin? Where are they located? Well, they're not located anywhere near us. So if I have this screenshot, this is way over on Lake Michigan. So if you were to drive from Baraboo, it would probably take you a couple hours to get to Lake Michigan if we drove due east. And then you would have to go north, probably another hour. Once you get to the Manitowoc area, the Two Rivers, places like that, you're starting to get close. And so these two power plants, these two nuclear power plants, are actually pretty close together. And they're located on Lake Michigan because they use a lot of water. All power plants use a lot of water. If we were to back up to the Columbia Power Plant, you would notice that there's a huge lake right next to it. And here's the Wisconsin River right next to that. So again, located near water. And similar to the Columbia Power Plant, this power plant down here actually has two reactors. Now, I'm not sure if we can still get into it, but years ago, I actually took my kids when they were little. They had a really nice visitor center here. And we were able to go in there. We were able to learn a lot about nuclear power. At least my kids were able to learn a lot about nuclear power plants. And then you could actually look out the window at the power plants. Now, for obvious reasons, they're not offering people opportunities to get in here and tour. Now, do we have any other nuclear power plants in Wisconsin? No. Do we have any nuclear reactors in Wisconsin? Actually, we do, and I've actually been able to tour that one. The University of Madison has a working nuclear reactor. It's not producing the power, but they do have a nuclear reactor there, and it's for research purposes. So if you ever go to school there and you get into certain programs, you might work with that nuclear power reactor to do some research and whatnot on it. So what does a power plant really consist of? Well, if we were to go to the Portage Power Plant, one of the things you would see in the Portage Power Plant, or the Columbia Power Plant, or the Alliant, Power Plant, whatever you want to call it, it burns coal. And I used to think that that coal was burned as large chunks, but it's not. Mr. Phillips and I we had a chance to tour it quite a few years ago. And they actually take those big chunks of coal and they grind it up into a fine powder, and they blow that powder into the area where it's going to get burned, and that's what burns. And what that heat does is it boils water. That boiled water creates steam. That steam spins a turbine, and that turbine spinning, and I'll show you this on a model coming up, that spinning turbine is connected to a shaft which goes into a generator which creates the electricity. In this case, then that steam is going to eventually be cooled down, and then it's going to be reheated again, and it's going to go through this process over and over and over and over again. Now, most power plants are similar to this. A nuclear power plant, they don't burn coal, but they use uranium to create a nuclear reaction that creates the energy or the heat, which boils the water, which does the same thing as a coal-burning power plant. Now, maybe you've been driving around the Portage area, especially on the other side of Portage as you go towards Beaver Dam or Fox Lake, and you notice all these wind turbines. Are wind turbines similar to this? They are. So instead of having something burn or a nuclear reaction happen that heats the water, that creates the heat that boils the water, wind turbines simply have air or wind spinning the turbines, which is connected to the shaft, which creates which goes into the generator, which creates electricity. Are hydroelectric dams similar to this? Yeah. But instead of using the heat, they actually just have the water spinning the turbines instead of the steam. So that's basically how a turbine, or that's basically how a generator produces electricity. So here's a generator that we have in a classroom, but unfortunately with COVID right now, so if you're watching this video in other years, I created this during the COVID era when we had virtual learning, so we had to talk through this. Otherwise, I could demonstrate this to you. So we're going to watch a short video on how this works. All right, so here's a video with a generator, one that you just saw. And here we are hooking it up to a voltmeter. Well, actually someone is. That's not Mr. Phillips or I. And this generator will produce electricity. Now, is this generator going to produce enough electricity to power your entire house? No, it's not going to produce that much. But we did put a voltmeter on it so you could see how much it produces. So basically, in a nutshell, you've got magnets right here. That's why you have the south and the north. You have copper wire in a coil. And then what we're going to do is we're going to spin it. So in a normal, like the Columbia Power Plant, they're burning coal to spin, to create the steam, to create, spin the turbine. We're going to do it ourselves. Now what's happening is you have a magnetic field here and you have copper wire that's spinning. And what that does is it gets the electrons flowing. So it's hard to see right here, but the light is actually on. So you can also see it here in a voltmeter. The faster you spin it, the brighter the light gets. So this is simple. This is the simplest way you can to produce electricity. Again, now this isn't going to power your house, but this in a nutshell is how a power plant works. This is how a generator works. Now I might say, well, I've got a generator out on the farm, or we've got a generator at our place. It doesn't look like this. Well, your generator is going to have a motor on it. You're going to put gas, you're going to gas it up, and that's where it's going to get its energy. It's chemical energy. And it's going to burn that gas, and the motor is what spins and if you can't see it right here, but this wire or this cord goes down to the magnets, or below the magnets, and connected to the copper wire, and that spinning motion is what's going to create the electricity. So your motor in your generator does that automatically for it. I guess you would want to call it the motor. So is this the same as like the motor that's in my drill? Well, your drill actually uses electricity to create this motion, where this generator right here, actually it's you spinning it, which creates the electricity. So a generator produces the electricity. A motor uses electricity to spin things or to move things. So let's go ahead and let's go back to the slides. And let's finish the slides up. So I still haven't told you what to put on that page if you have the book, or what to put on your online book where it says your teacher will provide instructions for you, but that's coming up really quickly. So what is the evidence that electricity is produced? Well, you saw in the video, one, the light bulb was lit, and the voltmeter registered that electricity was flowing. When the crank is moved, why does the intensity of the light of the bulb vary? And you can see when that person was cranking really fast, that light bulb got really bright. And when the person was cranking really slow, the light bulb was very dim. Or if they stop cranking, you have no light. Which energy transformations occur in this demonstration? Well, in the demonstration that you just saw, it was kinetic energy to electrical energy and then to light and thermal energy. And you might say, thermal energy? Where was there thermal energy? Well, you know, light bulbs are going to get warm. And that's where the thermal energy comes from. So electrical energy is the energy carried by electrons moving through a conductor. This motion is called the electrical current. There are two conditions for electrical energy to be present. One, you need a closed conducting circuit, and we've been talking about circuits in 9.1 and 9.2, and you have to have an energy source. In the video you saw, the person was the energy source. They're the one that was spinning it. So electrical circuits can transfer energy from a source to electrical devices, where it can be transformed into other types of energy. And that's what you saw. There was a circuit, there was wires that went from the generator, you know, from where you were cranking, it was spinning the coil of wire. And then there was well, I can show you. Right here, you can see the connection. So that circuit is producing electricity. The electricity will flow here. It'll go through the light bulb, then it goes through the wire, and then it comes back. Now, if we were to reverse and spin it in a different direction, the electricity just flows in a different direction. It'll still produce enough electricity to light the light bulb. That won't matter. So this is what I want you to add to your books. Go ahead and type this in. And if I talk too fast, just pause the video. What does an electrical generator do? One, an electrical generator converts mechanical energy into electrical energy. So it might have been the steam spinning the turbine, which is connected to a shaft, which goes into the generator, which spins it. In the video you saw, it was a person turning it. It could be wind for a wind turbine. It could be falling water for a hydroelectric dam. And then it can be fueled, powered by coal. We can use oil, we can use natural gas, we can use uranium, that's the nuclear, wind, water, all those. Or theoretically, you could. Imagine if your parents had a generator connected to a bike. You could sit and spin the bike and pedal the bike, and it would produce electricity. Now, it would also get you in really good shape as well, but that's not nearly as common. So the last thing we want to do is add these scientific principles. I believe we've already gotten to them in prior units. I think in 9.2 we did it, but go ahead and add them if you need to add them. And as always, if you have any questions, make sure you ask your science teacher. Thanks. Bye.